Hello, this video should help demonstrate the current divider rule. Following from Kirchhoff's current law, which states that the algebraic sum of currents entering and leaving a junction must equal 0, we can utilize this law to produce the current divider rule. Since the current in must equal the current out, the branches of a parallel circuit must split the source current in relation to their separate resistances. As shown in this circuit, we've got 3 branches, each with a resistance of 5 ohms, 10 ohms and 15 ohms. The source current is 15 amps, and by Kirchhoff's current law there must be a 15 amp current coming out. By the current divider rule, the current will split with a ratio equal to the inverse of their resistive values, and is shown in this equation here. The current of a branch is equal to the total current multiplied by the resistance of the total circuit divided by the resistance of the branch. As shown here, so first we find the resistance total, which we find to be 2.73 ohms, and the total current is equal to 15 amps. Plugging this into our equation, we find that I1 is equal to 8.18 amps, I2 is equal to 4.09 amps, and I3 is equal to 2.73 amps. Notice as we increase the resistance values, the current becomes smaller. We should also check by Kirchhoff's current law that the resistance total is indeed equal to the sum of each individual current component, which, using our exact values here, we do find that is indeed equal to 15 amps. Moving to a special case of a 2-branch circuit, we find that the current of a branch is equal to the total current times by the opposing resistance divided by the total resistance of the circuit. This follows the fact that as the smaller the resistance, the greater the current in its branch. This is shown in this equation here, that a current in a branch is equal to, as I stated before, we know that IT is equal to 5 amps, and so we plug this into our equation, 5 times 15 on 20, which we get the branch in I1 is equal to 3.75 amps. I2 is then equal to 1.25 amps, and to check again that the sum of these is equal to 5, 3.75 plus 1.25 does indeed equal 5 amps. When the resistances in a 2-branch system are equal, the current will split evenly. So in this case, we've just got 5 divided by 2, which is equal to 2.5 amps in each branch. And as I said, 2.5 times 2 is equal to 5, which follows Kirchhoff's current law. So hopefully this gives a greater understanding of the current divider.